Okay, here's the next installment of the Algebra 2 Semester 2 final review, and these are model problems. We'll start here with number 9. Our goal is to factor this expression, 5x cubed minus 80x. You should always look for a GCF first. In this case, there's a 5 and an x in both of them. So when you take out that 5x, you end up with 1x squared. And then dividing 80 by 5, you get minus 16 there. Now the second half of that, the x squared minus 16, is what we would call a difference of squares. And to get the x squared, you multiply x times x. You always use opposite signs on these type. And the 16 is 4 times 4. Now you can check this. Well, you can do it by storing a value for x and typing the top and the bottom to see if they match. But the other way is just to FOIL it out. There's your x squared. Here's your minus 16. You've got a 4x minus a 4x that doesn't appear up there because it cancels. And then to check the previous step, you distribute. Okay, here's another example, and you'll notice on problem 10 that we're starting with a negative value. If your leading coefficient, in this case the negative 12, is a negative number, you want to pull out a negative GCF, even if you just pull out a negative 1. But here it's going to be negative 3x. And negative 3x times the first blank has to give that negative 12x cubed. So we'll put a 4x squared there. And then the back half has to be negative 25. And you can distribute here to check that initial step. That would give this one. And the second half of the distributing gives negative 75x. Okay, and hopefully you recognize the back half as being a difference of squares problem. So they're both perfect squares. The 4x squared is a perfect square, and so is the 25, and there's a minus sign between them. This would be 2x times 2x to get the front half, 5 times 5 to get the back half, and the signs always alternate. And that one's done. Okay, a little bit more difficult when we have a trinomial. And this year I taught you the star method, so we're going to first of all look for a GCF. In this case, these numbers all divide by 4. Let me make sure that's right. Yep, they all divide by 4. 76 divided by 4, just for future reference, is 19. Okay, so we're going to take out an x also. Okay, now we're going to go ahead and set up our answer here. And go ahead and do the star method here. Our leading coefficient here is 6. And these two numbers multiply to give negative 120. And they add to give negative 19. Well, we want to find two numbers that multiply to give negative 120 and add to give 119. So on your y1 line, type 120 divided by x. It'll help you find the factors of 120. Then set your calculator in automatic mode and go to your table. And then scan through it looking for a pair of numbers that you might be able to get 19 out of. And I see it right there. It's 5 and 24. And to make this work, you're going to have to put the negative on the 24. Double check. 5 times negative 24 should equal that. And 5 plus negative 24 should add up to that. Now the right-hand side simplifies to 1 over negative 4. And we now know how to fill in the blanks up there. 6x plus 5. That would be from here. And the 1x minus 4. Okay, number 12 is slightly different. It's already factored for us. And we're supposed to find out the actual values of x. Now it does say equals 0, which is really nice. Because when you have one factor times another factor, and it equals 0, then what you know ahead of time is that one of them, at least one of them, it might be the first one, equals 0, or it might be the second one equals 0. Well, this is the easy one. If you take 4 over, you get negative 4 over, you get 4 for an answer. Here there's actually 2 steps. You take the 6 over and divide by 5. So the answers are negative 6/5 and 4. Okay, on 13 and 14, we're going to be doing, on 13, we're going to be solved by factoring. And that approach requires us to have it equal 0. So I'm going to bring the 14, I'm going to bring the 14 back over to the left-hand side. And then I'll use my star method to break this open here. Let's see, we have a 5 to start with. These two numbers multiply to give 40. And we need two numbers that multiply to give 40 and add to give negative 14. I don't think we need a calculator on that. 10 and 4 will work just fine if they're both negatives. Okay, this side is 1 over negative 2 is how we write it. And the other side doesn't simplify. So, and 1x minus 2, and the other side over here is 5x minus 4. Okay, we just set these equal to 0 and solve, which leads us to 2 and 4/5. Okay, on number 14, we have a different situation here. What we have is there's no linear term. You can see here that there's an x squared term and constants. When that's the case, you're going to take a different approach. You're going to get that x squared by itself. So first we'll subtract 6. And then you divide by 3. So now you've gotten that goal accomplished. You've got your x squared by itself. Once you've done that, you simply take the square root of both sides. Now you got to remember not to just write it like that. You got to put the plus or minus there. And you'll probably end up having to break some stuff up here into different radicals here. The perfect square that's trying to hide in that 20 is 4. And so you end up with plus or minus 2 root 5 for your answers. And that's called the square root method. We're going to see it again on the next problem. And so what we have here is we have this part here is squared, and everything else in the problem are constants. So that's when you use a square root method. Add 6 to both sides. So that'll be 48. Resist the temptation to distribute here. You can't distribute underneath a squaring or any other exponent. You have to divide by 2 here. So now I've got my squared part by itself, and over on the other side there's 24. At this point you get rid of the squared by square rooting, and you'll have some work to do in a minute here on the right hand side. We're going to break up the 24 into perfect square of 4 hidden inside the 24. So now it's going to be x plus 4 equals plus and minus 2 root 6. And now the 4 comes over and drops in as a negative 4 in front of the plus or minus sign. Okay, that's how you solve that one with the square root method. And number 16 is the start of a new section that I'm going to cover that has to do with imaginary roots, but I'll go ahead and do this problem since it's right in front of me. You could think of this as being the square root of negative 1 times the square root of 121, which is I times 11, but we just write it as 11i We normally put the imaginary unit behind the other one. Okay, so that concludes problems 9 through 16 on the review.